Energy Conservation and Baseball Impact by Christian Martin, Caden Taylor, Adam Zemecki, and Stetson Smither for the Dynamics Term Project for Spring 2026. Problem Statement. The goal of this project is to demonstrate the collision between a baseball and two distinct bats of different materials. A white ash wood bat and an aluminum alloy one-piece bat. We use the method of conservation of momentum and coefficient of restitution to quantify the difference in exit velocity and swing speed. This presentation will cover the motivations of our project, the bat characteristics, the momentum methods, assumptions, results, math and video comparison, and finally our conclusion. For our motivations, we wanted to figure out what is important about our bats. Most importantly, our metal bats include a trampoline effect, which can increase the exit velocity of the ball by 8 to 12 miles per hour. Metal bats also have a lighter swing weight and larger sweet spots, meaning it's easier to hit the ball. Wood bats pull more from raw power, but they have a smaller sweet spot, making it harder to hit the ball. Wood bats are also more useful for training timing and aim, since they don't rely more on the bat and more on the form.
Alright, the first bat we have up is our metal bat. The model is a Marucci F5. It has a length of 31 inches and a mass of 28 ounces. Its material is an aluminum alloy and it is BB Core certified, which means batted ball coefficient of restitution, which is something most metal bats have to have in high school leagues, little leagues, and even college. The next bat is a wooden bat. It is a Rawlings Hard Ash Pro. It is 33 inches with 30 ounce weight. It is made out of northern white ash wood. It has no BB Core certifications or exit velocity standards, so it is just the baseline wooden bat.
In the project, we analyzed the collision of a baseball between two types of bats, one ashwood and the other aluminum alloy. To compare their performance, we used the following theorems, with the first being average velocity. This helped us estimate swing speed between the bats and compare velocity. Next was conservation of momentum, which allowed us to relate velocities before and after impact. Finally, we utilized the coefficient of restitution, which measures how elastic the collision is, which helps determine how much energy is retained during impact, and it also affects the exit velocity of the baseball. To refine our analysis, we made several assumptions. First, the coefficient of restitution value used in calculations was 0.546, since this correlated with data from the MLB for professional grade baseball. Second, we neglected the effects of gravity in calculations, since contact time is extremely small between the baseball and the bat. Third, we neglected ball spin and plane of impact, which allows focus on linear motion without introducing rotation. Overall, the main focus is the conservation of momentum and energy transfer between the baseball and the bat, and focusing on this allows an effective comparison between the two.
To obtain our results for the metal bat, we split the calculations into 4 sections. We found the velocity after impact of the ball first. This was done by counting the number of frames the ball took to travel 40 feet and divided that by the frame rate of 240 to give us the travel time. Then we divided the 40-foot distance by that travel time to find the speed of the ball. This resulted in a ball speed of 80.22 miles per hour. Next, we used the law of conservation of momentum to obtain the first of 2 different equations. Then we used the coefficient of restitution formula to relate the bat's velocity before impact to its velocity after impact. This gave us equation 2. Last, we substituted the VBAT before impact into the first equation to solve for the bat's velocity after impact. This was found to be an average of 46.82 miles per hour. And the metal bat speed before impact was 61.17 miles per hour. For the wooden bat, we performed all the same steps except the ball speed after impact was found to be 72.73 miles per hour instead of 80.22, and the bat weighed 2 more ounces than the metal one. These slight changes led us to find that the wooden bat's velocity after impact was 42.76 miles per hour and before impact was 54.89 miles per hour. Once we knew the initial speeds of both bats, we compared the momentum of the two. Because the metal bat was lighter and shorter, its momentum was about 5.81 pound-feet per second higher than the wood bat. Then we compared the relative ball speeds by finding the difference of initial swing speed and exit ball speed of the metal and wood bat, which was 19.05 and 17.84 miles per hour respectively. By comparing those two speeds, we found a 1.21 mile per hour difference in ball speed between the two materials.
Alright, what we have going on here is two videos showing the difference on how a baseball comes off the bat compared to a metal bat and a wooden bat in slow motion. On the left, we have the metal bat. As you can see, makes contact, and then it's got some rise to it. It's somewhat with how I hit it, but like personally, for me, that felt more comfortable to swing the metal one. It felt like it had more pop off the barrel, and it was just easier to manage the speed. On the right is the wooden bat. It was a longer bat and it weighed more, but we took that into account in our calculations. As you can see, the ball doesn't have that same jump off the bat. It kind of just travels in a straight line instead of this rising kind of like zip off the bat.
As shown here, the collision between the bat and the ball happens in a relatively quick amount of time, but the differences in material properties can significantly influence the outcome. The aluminum bat tends to return more energy to the ball due to its higher elasticity, while the wooden bat absorbs more energy, resulting in a lower exit velocity. These differences show how material properties directly impact performance, thus highlighting the effect the coefficient of restitution has on bat performance.
Overall, exit velocity wise, we found through our calculations and just personal preference that the metal bat did have a higher exit velocity, on average around 1.21 miles per hour faster than the wood bat, but this was regarded with respect to their individual swing speeds because one bat was heavier than the other. As far as swing comfort is concerned, the metal bat felt like it transferred its energy a little better. It felt like it was good at like translating the swing power into just velocity for the baseball, and it wasn't like as raw feeling and aggressive as a wooden bat is, because a wooden bat can be more rewarding, but the difference in momentum output was 0.13 slug feet per second, which the metal bat had the edge on that. And as far as swing speed is concerned as well, on average, our metal bat was able to be swung around 7 miles per hour faster, but keep in mind it was lighter. Overall, our recommendation through our calculations, personal preference, and just work with both of these bats is that for someone learning baseball or anything like that, we would recommend a metal bat is more approachable, but it would still give similar results to a traditional wood bat.